Hi guys, welcome back to Think Tank Online Learning. So in this video I want to check whether this function is continuous at 0.00 or not. Okay, so I've given this function. Okay, so if you look at this function, as you can see, x squared plus y squared sine 1 over root x squared plus y squared, it looks like it is very hard, but what we're going to do, we're going to use what you know to find what you don't know. Okay, so I have sine. I'm not concerned about what is inside the sign, but I have something I know about the limit of sine x. Okay, we know that the limit, let's say as x approaches infinite, of sine x over x is equal to 1. Okay, so now that means I have a clue. Okay, then my second clue, if you look, we have x squared plus y squared under the square root, and you also have x squared plus y squared outside the square root. Okay, so what we're going to do, we want to try to arrive at this stage. So I'm going to use two methods. Okay, first of all, I'm going to use polar coordinates. I'm going to use polar coordinates. Okay, we know that r squared is equal to x squared plus y squared. Okay, so that means the square root of x squared plus y squared is equal to r. This function should be defined at the origin. So as you can see, it is defined at the origin. Then the limit at this point should exist, and I'm going to calculate the limit. Okay, then the limit at this point should be equal to the value at which the function is defined. Okay, so what I'm going to say is that instead of writing x squared plus y squared, I'm going to say limit is r approaches 0 of r squared sine 1 over r. Okay, and now what I want is that I want sine x over x, so that means I want 1 over r on the bottom. Okay, we can make that happen. Okay, let's say, what if we say, let's multiply by 1 over r. Okay, we've multiplied by 1 over r, but we've violated some mathematical principles. So what we're going to do, we don't need this 1 over r, so we're going to multiply by 1 over r on top, and look, this divided by this is just 1. So if you just change the appearance, the value of the equation is still the same. Okay, and what we're going to do, I think we're going somewhere. So if we say limit, let me write in red, limit is r approaches 0. Okay, I'm going to say r squared times 1 over r sine 1 over r divided by 1 over r. Okay, yes, like this. And look, this is same as this, so of course I'm going to take the product of the limit. Okay, so the limit here is going to be, the limit is r approaches 0 for what? For r squared 1 over r times the limit is r approaches 0 for sine 1 over r over 1 over r. Okay, and what is this? We know, okay, we can just cancel 1r into r squared. We're going to get r, and the limit here, we're going to just substitute the number. So the limit is going to be 0 times, we say this is 1. Okay, so it's going to be 0 times 1. So that means the limit is 0. Okay, so first we say the function is defined at the origin. That was our first condition. f(0,0) is defined at the origin and it goes to 0. Then the limit is xy approaches 0,0 of x squared plus y squared sine 1 over x squared plus y squared at this point is equal to 0. Then what is our last condition? Since this limit, okay, I'll run out of space, I'm not going to write. Since this limit, the limit here, is equal to f(0, 0), therefore the function is continuous at this point. Okay, but there's some people who hate polar coordinates. So what we're going to do, we're not going to change anything into polar coordinates. What we're going to do, we're going to check if the function is continuous without changing the rectangular coordinates to polar coordinates. It is still the same. What we're going to do is still the same as we did. Okay, we're going to use the same concept of saying limit of sine x over x, as x approaches 0 or infinite, is equal to 1. Okay, so what do you want here? We have this function. Okay, so now our limit, what if we say, look, when you calculate this using polar coordinates, we divide by 1 over r squared. Okay, so here we want to divide, we're going to say limit as xy approaches 0, 0 of x squared plus y squared sine 1 over x squared plus the square root of y squared. Okay, we said we wanted this as the denominator, so I'm going to write it as the denominator. Let's write it as the denominator, 1 over x squared plus y squared. Okay, but we said we violated some mathematical principles, so we have to multiply it by the same function or number. Okay, so now if you look at this, the value of the equation is still the same, but this same is multiplying by 1 over 1. Okay, and now we're back. I'm going to say limit as xy approaches 0, 0. Okay, I'm going to say x squared plus y squared times this one. So this is going to be x squared plus y squared to the power of, okay, times what? Times sine 1 over x squared plus y squared divided by 1 over x squared plus y squared. Okay, and as you can see, we're good here. Okay, so what we're going to do, we know, we're going to take the product of the limits, and we said this one is equal to 1. Okay, so let's just write times here. What about this? Okay, if you plug in 0, we have 0 at the denominator. Okay, but let's look, this one is the same as this one. It's the same as saying a divided by root a. Okay, so you can just say a divided by a to the power 1/2. This same is saying a to the power 1 minus 1/2. Okay, so we're going to say x squared plus y squared to the power 1/2 limit as xy approaches 0, 0. And if we plug in 0, 0, we no longer have a denominator, you no longer have a fraction. We're going to get 0 times 1, and the limit is still 0. Okay, so you choose what you like. Okay, but I think working polar coordinates is very easy. Instead of writing this whole thing, I'm going to just write r squared, and they're going to just write r. Thank you for watching. I hope for your support in form of comments, likes, and shares. Okay, have a good day.